This video is for day 5, which is the first day of the second week. We're beginning section 7.2, which is the sum and difference of angles identities. If you have not already, please pause the video now. Go to Google Classroom and find the identities over here on the right hand side of the page, or just pause it here, get them in your notes. And yes, you are required to have a notebook. I will have you upload pictures of that notebook for credit. We're going to find the sine and cosine of non-special angles using these identities with special angles. The first one I'm going to do is the sine of 15, which is not a special angle, which implies that you're going to need to know your unit circle, which you already have known but probably forgotten, so you need to go back and get that also. We need to make 15 into either a sum or difference of two angles that we know are special angles, and this shouldn't be too difficult for you. If I take 60 and, well, that's not right. If I take 45, whoops, that's still the eraser. If I take 45 and subtract 30, which are both special angles, that will give me the sine of 15. So the sine of 45 minus 30 is going to be right over here, the sine of alpha minus beta, which is going to equal the sine of alpha, which is going to be the sine of 45, times the cosine of beta. So we want the cosine of 30, and we're going to add to that the cosine of alpha, so cosine of 45, times the sine of beta, or the sine of 30. Now we've got all special angles, so the sine of 45 is root 2 over 2. The cosine of 30 is going to be root 3 over 2. We're going to add to that the cosine of 45, which is also root 2 over 2, times the sine of 30. The sine of 30 is 1/2. So that's going to be the square root of 6 over 4, plus the square root of 2 over 4, which gives me the square root of 6 plus the square root of 2 all over 4. And that would be your final simplified answer. The next example is going to be the tangent of 105, and it shouldn't take you too long to figure these out. They're going to be a little more difficult when we have the radian measures in there. And there's no one way of doing this. I picked 60 plus 45, but you could come up with another difference or sum which would work also. So now down here, the tangent of alpha plus beta is going to be the tangent of alpha, 60, minus the tangent of beta. And these do kind of have a rhythm to them, the identities, if you look at them. The tangent, of course, the numerator is opposite sign that's given, and the bottom is the same sign. All the cosines are cosine, cosine, sine, sine with opposite signs. The sines are sine, cosine with the same signs. Sine, cosine, cosine, sine. So on the bottom, I'm going to have 1 plus the tangent of 60 times the tangent of 45. All right, so the tangent of 60. 60 is in the first quadrant, and we're going to go with a root 3 minus the tangent of 45, which is 1, all over 1 plus the tangent of 60 times the tangent of 45. That's going to give me root 3 minus 1 all over 1 plus root 3. Oops. Now, we cannot leave our answer like that because it's got a radical in the denominator. So what we're going to do is, if I'm going to try to move the page up here, we're going to simplify this denominator by multiplying by the conjugate, which is going to be 1 plus the square root of 3 over 1 plus the square root of 3. Did I say plus? How about minus? Okay, so we're going to have to FOIL, so that's going to give me root 3 in the numerator. For my first terms, my inners is going to be minus 1, my outers is going to be minus 3, and the last terms is plus the square root of 3. the denominator, we're multiplying conjugate, so it's going to be the difference of the squares. So up top, I've got 2 times the square root of 3 minus 4 all over 1 minus 3, or a negative 2. So let's factor out a 2. That's going to be root 3 minus 2 all over a negative 2. The 2's cancel, and I can bring the negative to the numerator. So it's negative root 3 over, or minus 2 rather. And if I distribute that negative through, that's going to be 2 minus the square root of 3. A final example with degrees before we go to radians. Cosine of 285. Again, you're just going to have to come up with some combination of special angles. So I've got the cosine of 225 plus the cosine, well, cosine is 60. So 225 plus 60 is going to be 285. I got to go over to my sum and different angle identities, and I've got the cosine of a sum. So it's going to be the cosine of alpha. So the cosine of 225 times the cosine of 60 minus the sine of 225 times the sine of 60. And then right back to our unit circle. 225, third quadrant, the cosine is going to be negative. So that's going to be negative square root of 2 over 2. It's got a 45-degree reference angle. The cosine of 60 is going to be 1/2 minus the sine of 225. So now we've got a reference angle of 45. The sine is also negative in the third quadrant. So it's going to be minus the square root of 2 over 2. And the sine of 60, is going to be root 3 over 2. So we're going to multiply these together first. Negative root 2 over 4. Let's just go with a plus because this is going to be a negative and a minus. So it's going to be plus the square root of 6 over 4. So it looks like we're looking at minus square root of 2 plus the square root of 6. Or we just write as square root of 6 minus square root of 2 all over 4. Nothing can simplify there. So that's our final answer for that one. Okay, now we're going to do this with radian measures. So we're going to have the sine of 7 pi over 12. You got to remember special angles have denominators of 3 for 60 degrees, 4 for 45 degrees, 6 for 30 degrees, and 2's for the 90 degrees. So 12 could either come from a 6 and a 2 or a 3 and a 4. I'm going to choose a 3 and a 4. I'm going to add them together. And to get 7, we're going to take the just 1 pi over 3. That's going to give me 4 up top. And 1 pi over 4, and that's going to give me 3 on the bottom. I'll show you exactly what I mean here. That's the sine of pi over 3 plus pi over 4. That is pi over 3 plus pi over 4, common denominator of 12. So the left one needs to be multiplied by 4 over 4, so 4 pi over 12. And this one needs to be multiplied by 3 over 3, 3 pi over 12, which gives me my 7 pi over 12. Like I said, they're a little more difficult, but I'm pretty confident you guys can do it. Let me get that out of the way over here. Okay, so again, sine of a sum. So we're going to go to this guy right here. So it's going to be the sine of pi over 3 times the cosine of pi over 4 plus the cosine of pi over 3 the sine of pi over 4. So that's the sum of a sine. So sine of pi over 3, that's a 60 degree. So that's my y value on a 60 degree, which is going to give me a root 3 over 2. Times cosine of pi over 4, that's going to be a root 2 over 2, plus the cosine of pi over 3. The cosine is the x value, so that's going to be 1/2 times the sine of pi over 4, which is going to be a root 2 over 2. So multiply these together. We got root 6 over 4 plus root 2 over 4. And that's going to give me root 6 plus root 2 all over 4. Okay, I think this will be the last example. We've got a cosine of 5 pi over 12. 12 can come from 3 over 4. It can come from 6 over, 6 and a 2 or a 6 and a 4. It just takes some time and effort just to play around with these. I'm going to go with the cosine of pi over 6 plus pi over 4. And you need to check. That's going to be something pi over 12 plus, and it could be minus, something pi over 12. So that's going to be 2 pi over 6. I'm sorry. Yeah, 2 pi over 12. That would be pi over 6. Pi over 4 is going to be multiplied by 3, so it's going to be 3 pi over 12. And if I add the 2 and the 3 together, that's going to give me my 5 pi over 12 that I need. So indeed, this is the cosine of the sum of those two angles. Not the only way to do this problem. You could come up with a couple other things. Well, I guess I messed that up. So that was the cosine of pi over 6 plus pi over 4. All right, so we have the sum of the cosines. That's the top one over there. It's going to be cosine, cosine. So I've got cosine pi over 6 times cosine pi over 4 minus the sine of pi over 6 times the cosine of pi over 6. Nope, pi over 4. Back to the unit circle. Cosine of pi over 6, that's a 30 degrees, so it's the x, so it's going to be root 3 over 2 times cosine of pi over 4, root 2 over 2 minus sine of pi over 6, that's going to be 1/2, and the cosine of pi over 4, which is going to be root 2 over 2. So we've got root 6 over 4 minus root 2 over 4. So that's just going to be root 6 minus root 2 all over 4. All right, hopefully you don't find these too difficult. The ones with radians, you just got to play with them a little bit and write out some angles and see what you come up with. Check Google Classroom. I'll have a little assignment up there for you. And again, like I said, I do expect you to have a notebook with these in. So when I ask you to upload the photos of your notebook, don't be surprised. All right, guys, have a great week. I'll talk